Welcome, welcome, Wildcats. Today we are going to begin our brand new unit. We just finished our Unit 5 test, so let's take a look at the beginning of our next unit, which is 1.4b, quadratic and square root inverses. Wait, we just finished Unit 5. Why are we looking at Unit 1? That can't be right. 1.4c, cubic and cube root inverses. That also can't be right. That's still Unit 1. Unit 6, 6.1, inverses of quadratic and cubic functions. Wait a minute. That sounds a lot like cubic and cube root inverses and quadratic and square root inverses. And we're even going to be working with simple ones? Bet. So, obviously I'm being a little silly here, but does this look familiar? Quadratic and square root functions are opposites. The inverse of a quadratic is a square root. The inverse of a square root is a quadratic. Hopefully all of those look familiar to you. But what about this? Cubic and cube root functions are also opposites. The inverse of a cubic is a cube root. The inverse of a cube root is a cubic. Those all look familiar too. So am I telling you I already did this? Pretty much. We did pretty much exactly this back in the first 6 weeks. So if you still have your notes from 1.4, a lot of those are still going to be very useful. Let's take an actual look at an example from 6.1 though. How are we going to do this? Well, for quadratic functions, step 1, you're going to find the x value of the vertex. Remember, generally speaking, we call that h. Step 2 is you're going to restrict the domain. You're going to say that x can be any number where x is bigger than that x value of the vertex. Now the reason for this is because we want the inverse to still be a function. And if you think about it, if you take a u and you put it sideways like an inverse is going to do, it's not a function anymore. So what we do is we take the u, but we're only going to take half of it, and when we flip it over, it's a function. That's why we're going to restrict the domain. The third step is to find the inverse. So after we've restricted the domain, we have to find the inverse. If you don't remember how to do that, there's going to be a review for how to do it in 2 slides, so don't worry about that. So step 1, find the x value of the vertex, the h value. Restrict the domain to the set of all numbers x such that x is greater than or equal to h. Step 3, find the inverse. Now as for quadratic functions, for cubic functions it is a little bit different. So step 1 is going to be to find the inverse. And again, next slide is going to show you how to do that. Step 2 is going to be to remember that there is no step 2. So cubic functions, because of the way they work and the way they look, when you flip them over, they're still functions. So we don't need to restrict the domain. This means cubic functions are easier when you're talking about inverses. Needless to say, we like cubic functions for inverses. So let's go ahead and take a look at an example. This is an example from 1.4b. Step 1 of finding an inverse is to switch f of x to y. Step 2 is to change x and y. So by that I mean flip them, flip their position. Step 3, solve for y. Get y by itself. Isolate y. Whatever way you want to word that to remember that you need to get y by itself. Hopefully you guys will remember that that requires you to use PEMDAS backwards. So you start with addition, subtraction, work your way backwards down the line. Finally, step 4, you're going to replace y with f inverse of x. So let's say, for example, we have f of x equals x squared plus 3. Well, step 1 is to switch f of x to y. Just like that. Step 2 is to change places, change x and y's places. Just like so. For step 3, we're going to solve for y. That's PEMDAS backwards. Well, we start with addition and subtraction. I see a plus 3 at the end. The opposite of plus 3 is, of course, minus 3. So we get x minus 3 equals y squared. Then as we work backwards, is there any multiplication or division? I don't see any. Are there any exponents? Yeah, we have y squared. As I've been saying this whole time, the opposite of squared is square root. So we'll go ahead and take the square root of both sides. So we end up with y equals the square root of x minus 3. Finally, when we replace y with f inverse of x, we get f inverse of x equals the square root of x minus 3. That's really all there is to it. Just make sure you follow all 4 steps. And as you follow them, make sure that you are doing PEMDAS backwards and not forwards. One last thing to take a look at here. They're going to ask you about the composition rule several times in this particular assignment. So, 2 functions are inverses of each other if their composition equals x. We talked about the composition rule back in that first 6-week period. We had f of g of x. We wrote it f parentheses g parentheses x close close. The composition of f with g. Every once in a while, I don't know if we had any problems with it, but I told you that you might see it as fog, f of g of x. Still read the same way. For this particular section, pay close attention to what's about to pop up right here. We're going to see f of f inverse of x. So instead of having f of g, we'll have f of f inverse. They're going to ask you if f of f inverse of x equals x. And what the composition rule says is if it does, then they're inverses. That's all they're asking for there. Don't overthink it. Just plug it in. You'll be fine. With that, you guys have absolutely everything you need to do 6.1's homework assignment. So with this quick 8.5 minutes, hopefully you guys are well on your way to realizing that Unit 6 is going to be one of the easier ones that we've had because it's literally stuff that we've already done. And it wasn't even the hard stuff that we've already done. As always, if you need help, room 215, you know where to find me. I can also be got by email if you can't come to my class. Either one is fine. Good luck, Wildcats.